Assalamu alaikum and good evening, everyone. Today we are going to start with question number 14. Hydrogen iodide is added to an evacuated reaction vessel. The reaction vessel is sealed and warmed. A decomposition of a reaction occurred. Hydrogen and iodine formed. Some hydrogen iodide remains. Okay, so it means if you see, it's this reaction, right? Forming hydrogen and iodine, and for that we need 2 moles. The equilibrium is established. The total pressure is 1.2 exponent minus 5 pascals. The partial pressure of hydrogen iodide is, okay, so it's the partial pressure of hydrogen iodide. Okay, if you write the Kp expression, so the Kp expression is going to be constant partial pressure of hydrogen times partial pressure of iodine over partial pressure of hydrogen iodide square. Right? Now, hydrogen iodide, hydrogen and iodine are all gaseous under the conditions used. Okay, now if you see, there is a very important thing. At the start, they have used only hydrogen iodide. So it means that in this, the partial pressure of hydrogen and the partial pressure of iodine is going to be equal because their mole ratio is 1:1. So for example, if let's say if 2 moles of hydrogen iodide is decomposed, we are going to get 1 mole of hydrogen and 1 mole of iodine. So if the moles are same, then the partial pressures of these gases are going to be same. Is this understandable to all of you? Now, what they are saying, what is the value of Kp for the equilibrium at the temperature, at this temperature, assuming the decomposition is a forward reaction? Okay. So, if you recall, let me do the working over here. Partial pressure of hydrogen iodide must be equals to mole fraction of hydrogen iodide times total pressure. And if I go for the mole fraction of hydrogen iodide, so mole fraction of hydrogen iodide is equals to partial pressure of hydrogen iodide over total pressure. So partial pressure of hydrogen iodide is 4.00 exponent minus 3 divided by total pressure, which is 1.20 exponent 5. Can anyone calculate and tell me the value, please? Yes, can anyone calculate the value of the mole fraction of? It's 3.3 exponent minus 8. Okay, remember it's a mole fraction, so it's a fraction. So remember, you must know that the sum of the mole fraction is always equals to 1 only. Okay, so the sum of the mole fractions is always equals to 1 only. So it means if I have to find the mole fraction of hydrogen and the mole fraction of iodine, I have to subtract 3.3 exponent minus 8 from 1. So I'm going to get the mole fraction of both of these. Can anyone calculate it and tell me the answer, please? Just 1 minus 3.3 exponent minus 8. Yeah, sorry. Thank you. It's exponent 3. So we are getting minus 8. Okay. So can anyone subtract it? Yes, Hassan, 1 minus 3.3 exponent minus 8. Okay. So it means 0.03 is the mole fraction of both of them. As we have just discussed that their partial pressure, sorry, and the mole ratio is same. So it means that is the sum of these two. So I have to divide it on dividing this value with 2. or making it half will give me the mole fraction of hydrogen and iodine, which are equals to each other. So can anyone divide it? I think you are going to get 0.015. Is this clear to all of you? Okay. Okay, so here you are getting 0.03. Okay. So if you subtract 0.03 from this, what value we will get? 0.97. So for 0.97 divided by 2, can anyone divide 0.97 by 2? 0.485 is the mole fraction of hydrogen and the mole fraction of iodine. Okay. So now, if I have to find the partial pressure of hydrogen and partial pressure of iodine, so it is going to be equals to mole fraction, that is 0.485 times total pressure, which is 1.20 exponent 5. Can anyone calculate this value, please? It's 58200. So we got the partial pressure of hydrogen and iodine. We know the partial pressure of hydrogen iodide is this. Now we have to put all these values in this Kp expression. So if you will put these values in Kp expression, it is going to be 58200 times 58200 divided by 4.00 exponent minus 3. Exponent 3, sorry. Can anyone calculate it and tell me the answer, please? Yes, can anyone calculate the answer, please? On calculating, you are going to get 1.28 exponent minus 3. Can anyone confirm it? So it's this 1.28 exponent minus 3. So B is the correct answer. A, C, and D goes wrong. Is this clear to all of you? Yes, Adina, Dua, and Mariam. Okay. Now question number 15. The equation for two reactions are shown. Reaction X, NOBr is decomposes to form NO and bromine, and NOCl decomposes to form NO and chlorine. Okay. The two reactions have similar reaction mechanism. The initial rate of reaction X is greater than that of reaction Y. Yes. So, when measured under identical conditions of temperature, pressure, and reactant concentration. So it means that, see, they have told you that this reaction is faster. Under the, if both are occurring in the same condition, so the reaction is faster. Okay. 1 minute, please. Okay. Which statement explains this difference? So obviously, if the reaction is faster, so it means that its activation energy is going to be lower and its activation energy is going to be high. That's why it occurs slowly. So the activation energy of reaction X is less than the reaction Y. Yes, this statement is correct. The bromine-bromine bond is weaker than the chlorine-chlorine bond. Yes, this statement is correct also. But if you see here, no bromine-bromine bond or no chlorine-chlorine bond is broken, right? So it means this statement goes wrong. And if this statement goes wrong, said then A and B are wrong. The higher frequency of collisions between molecule of NOBr occur between than the molecule of NOCl. So see, they are occurring at same temperature, pressure, and reactant concentration. So if their reactants, if their temperature, pressure, and concentration, these conditions are same, then the frequency of the collisions would not be higher for any of the reaction, but they are same. So third statement is wrong as well, which makes D wrong as well. So the correct answer is C. Is this clear to all? Because in 3, they are saying that, see, there is a higher frequency of collision. Not, they are not asking about the successful collisions. Yeah, obviously, there would be a higher frequency of a successful collision. That's why the reaction rate is faster. But if they are talking about the frequency of the collisions, so it's not higher. The overall frequency of both the reactions are going to be same because both the reactions are occurring at same temperature, pressure, and same reactant concentration. Did you get, Adina? Okay. Now question number 16. The diagram shows the Boltzmann distribution of energies in a gas. The gas can take part in a reaction with an activation energy, EA. The gas is maintained at a constant temperature. Okay. Which statement is correct? Okay. Okay. If the catalyst is added, peak P will be lower. No, there will be no change in the peak P, right? So A is wrong. If catalyst is added, peak will be no. Again, B statement is wrong. And activation energy move to the left. Yes, the activation energy moves to the left. That is correct. Activation energy move to the right. No, that is not correct. So D goes wrong as well. So we are left with only C. So C is the correct answer. Is this clear to all of you? Now question number 17. Okay, now question number 17. L, M, and N are three different elements from period 3 of the periodic table. L is the element whose atoms have 3 unpaired electrons in its 3p subshell. Okay, so it means it can be a phosphorus. M is the element with the higher electrical conductivity in the period. So it can be aluminum because it has a +3 it loses 3 electrons per atom, and is the element with the highest melting point in the period. So it's a silicon, right? Which statement about element L is correct? L has the higher atomic number than M. Yes, because if you see, phosphorus is 15, it's 15, it's 13, and it's 14. And a lower atomic number than N? No. So A goes wrong, right? L has a lower atomic number than M? No. L has a lower atomic number than both? No. L has the higher atomic number than both M and N? Yes, that is correct. So D is our correct answer. Is this understandable? Now question number 18. In reaction 1 and 2, X represents an element in period 3. Okay. In each reaction, X is forming a product where X is in the highest oxidation state. Okay. Which ratios show a steady increase from sodium to phosphorus? Okay. So if you see over here, if X is element from period 3, as they have told you, so if X is sodium, then it is NaCl. And if X is Mg, so it's MgCl2. If X is aluminium, so AlCl3. If X is silicon, SiCl4. If X is phosphorus, so PCl5. Is this understandable? In the same way, if X is sodium, so it's Na2O. If X is magnesium, then MgO. If X is aluminium, then Al2O3. If X is silicon, then SiO2. And if X is phosphorus, then P4O10. So in each, which ratios show a steady increase from sodium to phosphorus? So if you see from Y to Z, we are observing that there is a steady increase, and the same P to Q both. So neither Z is to Y nor Q is to P. It's wrong. Z is to Y only. No, because Q is to P is also showing the same steady increase. So all three first options A, B, and C goes wrong, and D is the correct answer, because here Z is to Y is showing the increase from sodium to phosphorus, and in the same way Q is to P is also showing the increase from sodium to phosphorus. Is this understandable to all of you? Now question number 19. Sodium, magnesium, aluminum, silicon, and phosphorus are all elements in period 3 of the periodic table. Three statements about the oxides and chlorides of these elements are given. The ionically bonded oxides all react with dilute hydrochloric acid. So these three are all ionically bonded, and they, due to this, they all are basic. So they react with the acid, right? So they all three react with the acid. So yes, first statement is correct. All metal chloride produces neutral solution when added to water. No, completely wrong. Because if you see, when we talk about MgCl2, it's has a pH of 6.5, so it's acidic, not neutral. And AlCl3 has a pH of 4 or 3 to 4, so it's also acidic. So if 2 goes wrong, which makes B, B, and A, all 3 goes wrong, so we are left with only C. So C is the correct answer. Is this clear to all of you? Now question number 20. The table compares calcium with the barium and calcium carbonate. Table compares calcium with barium and calcium carbonate with barium carbonate, which row is correct? Reactivity of elements. So if you see in the periodic table, we have beryllium, magnesium, calcium, strontium, barium. So down the group reactivity increases. So barium is going to be more reactive. So A and B statements are correct and C and D are wrong. Okay. Thermal stability. So down the group thermal stability increases. So barium carbonate is more stable. Yes, it's correct. Calcium carbonate is more stable. It's incorrect. So B goes wrong as well. And we are left with option A. So A is the correct answer. Okay, is this clear to all of you? Now question number 21. Okay. Now question number 21. Solution P and Q each contains a different group 2 ions at the same concentration. One cation is Mg2 positive and the other is Ba2 positive. Tests are carried out on separate 5 centimeter cube samples of P and Q. Add 1 centimeter cube of 0.1 mole per dn cube sodium sulfate. So if sodium sulfate has been added, then we get magnesium sulfate and barium sulfate. If you recall the solubility, the sulfate solubility decreases down the group. So that's why it is going to be formed as a precipitate and it's relatively soluble. When we add sodium hydroxide, we are going to get magnesium hydroxide and we are going to get barium hydroxide. So hydroxide solubility increases down the group, so it's more aqueous and it forms a precipitate because its magnesium is on the top. Okay, so more in test 1, it will form a precipitate, and in test 2, it will form a precipitate. For more precipitate with barium, more precipitate, wrong. More precipitate with barium, more precipitate with calcium, yeah. And, oh, sorry, barium, magnesium. So in these two, with test 1, we are getting more precipitate with barium. So C and D goes wrong. A goes wrong as well. And we are left with B option. So B is correct. Yes, very good, Adina. Now, question number 22. J dissolves in water to give an aqueous solution K. K gives a dense white precipitate when aqueous silver nitrate is added. So it means K must contain a chloride. Right? When heated with aqueous potassium hydroxide, K gives off a gas that turns moist universal paper blue. So it means that gas is ammonia. And if gas is ammonia, then it means K contains ammonium ion. So what is J? So K is the solution of a J. So it means J must contain ammonium and chloride ion. So it's ammonium chloride, not ammonium sulfate, not sodium chloride, not sodium hydroxide. So B, C, and D goes wrong, and A is the correct answer. Is this clear to all of you? Now question number 23. Ammonium sulfate and ammonium nitrate are used as a fertilizer. These salts have a different percentages by mass of nitrogen. They have the same effect as each other on the pH of wet neutral soil. They have the same effect as each other. Okay, which row is correct? Okay, if you work on the C, both have 2 nitrogen, right? If you calculate its MR, and if you calculate its MR, I think its MR is going to be 80. And if you calculate its MR 96, 96 and 28, 28 and 8. Sorry, 14 and 4, 18, 18 and 18, 36. So 36 plus 96. So see, so it has a greater MR, right? So it means percentage of nitrogen in it is lower and percentage of nitrogen in this was higher. So ammonium nitrate has a higher percentage of nitrogen and ammonium sulfate has the lower percentage of nitrogen. You can calculate it as well. Is this clear? So that's why I marked C and D wrong. Now, effect on the pH of soil. So if you recall ammonium, we talk about ammonium, that ammonium are, acidic. So if they are acidic, they decreases the pH of the soil. So B goes wrong. And A is the correct answer. Is this clear to all of you? Yes, now question number 24. Just give me a minute, please, everyone. Okay, now question number 24. The equation shows the reaction that occurs between carbon monoxide and nitrogen monoxide in a catalytic converter. Which statement is correct? A catalyst is uses finely divided iron. No, it's a platinum and rhodium. So A statement is wrong. The reaction prevents greenhouse gas emission into the atmosphere. No, carbon dioxide formed is a greenhouse gas, so it can't prevent greenhouse emission. So B goes wrong. The reaction reduces the possibility of formation of photochemical smoke. Yes, it is correct, because nitrogen oxides are not formed and they are the primary pollutants which are responsible for the formation of, greenhouse gases. Just give me a minute. Okay, yeah, sure. Okay. So the reaction results in increased ozone depletion. No, ozone depletion is by CFC. So we are left with only C. So C is the correct answer. Now question number 25. Okay, 25. Which compound which compound has the molecular formula of C6H10O? So C6. Okay. So if you see over here, there are two hydrogens, there are two hydrogens, there are two hydrogens, there is one hydrogen, and there is three hydrogen. So there are six carbons. If you count the hydrogens, 4, 5, 6, 7, 8, 9, 10. 10 hydrogens and one oxygen. So it seems to be correct. Let's have a look at this one. It's three hydrogen over here, three hydrogen over here, three hydrogen over here. So it's C6H12O. So B goes wrong. And if you see over here, two hydrogen, one hydrogen, one hydrogen, two hydrogen, one hydrogen. So C6. If you count the hydrogen, 4, 5, 6, 7. 7 hydrogen and oxygen. So C goes wrong as well. Two hydrogens, three hydrogens, three hydrogens, one hydrogen and two hydrogen. So 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's again C6H12O. So D goes wrong as well. So A is the correct answer. Question number 26. The general formula of non-cyclic alcohol is CnH2n plus 1 OH. How many different structural isomers if the value of N is 3 and the value of N is 4? Okay. So if they are talking about only structural isomers and with the alcohol only. Okay. So for 3 carbons, it's like this, and that is propane 1 all, and then that is propane 2 all. And if I switch to the left bore, it is again going to propane 1 all. So there are 2 possible structural isomers for this. So C and D goes wrong. Now, if we have 4 carbon atoms and carbon number 1 has OH, so it's butane 1 all, then it is butane 2 all, right? Then it is 2-methyl butane 1 all, and then it is 2-methyl butane 2 all. So there are 4 possibilities. So A goes wrong and B is the correct answer. Is this understandable to all of you? Now question number 27. Compound HC5H10O3 has 1 chiral carbon atom, very important. Compound X produces bubbles with Na but not with CO3. So it means compound X has alcohol and no carboxylic acid. And another thing that compound X must has that a chiral carbon. Because if sodium carbonate we are not getting bubble, it means there is no carboxylic acid in it. So if you see these two contains carboxylic acid, so C and D goes wrong. These two both contains alcohols, but if you draw A, you see CH3, C, CH3, OH, and CO2H. So 2 carbons are same, so no chiral center, so A goes wrong. It means B is the correct answer. And if you want to check whether it has a chiral center or not, so have a look. OH, CH2. So this carbon is not chiral, but the next carbon has H, CH3, and then CO2, CH3. So see, this carbon is actually a chiral carbon. So yes, B is the correct answer for question number 27. Now question number 28. Ethane reacts with an excess of a chlorine in the presence of ultraviolet light to form a mixture of the products. How many of these products contain 2 carbon atoms and 1 or more chlorine atoms? Okay, how many of these products contain 2 carbon atoms and contain 1 or more chlorine atom? Okay, I think I have discussed one such kind. Let me check. 2 carbon atoms and 1 or more chlorine atoms, right? 2 carbon atoms and 1 or more chlorine atom substitution. Yes, it's about ethane, right? To form a mixture of how many of these products contain 2 carbon atoms and 1 or more chlorine atoms? So this is going to be 1 because 2 carbon atoms and 1 chlorine atom. 2 carbon atoms and 1 or more chlorine atoms. 2 carbon atoms and 1 or more chlorine atoms. 2 carbon atoms and 1 or more chlorine. 2 carbon atoms and 1 or more chlorine atoms. 2 carbon atoms and 1 or more chlorine atoms. 2 carbon atoms. So yeah, we are getting 9. So there are 9 such products. Am I audible? Okay, let me share the screen. So it means the correct answer A, B, and C are goes wrong, and D is the correct answer, right? Now question number 29. When bromoethane, so bromoethane is two carbon atoms and over here bromine, reacts with hot ethanolic sodium hydroxide, NaOH in ethanol. Which type of reaction it is? It's an elimination and we are going to get alkene. With HBr, HBr is an acid, it reacts with sodium bromide hydroxide to form NaBr and H2O. So it is going to be aqueous, it is liquid, and this one is going to be gas. A colorless gas is formed. So this is the colorless gas, ethene. This colorless gas decolonizes bromine water. Yes, this test assures us that it is an ethene. What is the colorless gas? So it's an ethene. So A, B, and D goes wrong, and C is the correct answer. Is this understandable to all of you? Now, question number 30. Alkynes are hydrocarbons that contain one triple carbon-carbon bond. Okay. Like alkenes, alkynes take part in an addition reaction. A saturated compound can be formed. Okay. So it means that the triple bond is going to turn into single bond because they are saturated. For example, ethyne, and they have given you the formula, structural formula of ethyne, the displayed formula of ethyne, reacts when excess of hydrogen to form ethane. So it means when this one react, it will react with the excess of hydrogen to form ethane. So see, there is a double bond. So it means we need 2 moles of hydrogen to form ethane. There is some internet problem. Okay, so 2 moles of hydrogen are needed. Propine C3H4 undergoes an addition reaction with an excess of hydrogen bromide. So if you see propine, if you will make propine, so it is going to be CH3, C, triple bond, CH with excess of HBr. So with it reacts with excess of HBr, so it means it is going to form CH3, C, single bond C, and this H is already there. Okay. In 2 stages, Markovnikov's rule applies to the addition of HBr. So Markovnikov's rule says that hydrogen is going to bond to the carbon which has already more hydrogen. So between these 2 carbons, this carbon has already 1 hydrogen. So one H is going to bond over here and bromine is going to bond over here. Then when the other HBr reacts, so the hydrogen is going to bond over here and bromine is going to bond over here. So it's going to be CH3, CBr2, CH3. So see, the bromine is getting attached to 2 carbons, so goes wrong. 2 bromines are attached to terminal carbon, that goes wrong as well. 2 bromines are attached to different carbons, so goes wrong. So see, CH3, CBr2, CH3. So this is the correct answer. So our correct answer is D, 30. Is this clear? Now question number 31. Bromine reacts with with alkenes by an electrophilic addition mechanism in which a cation is formed as an intermediate. Which mixture will produce the most stable intermediate cation? Okay, so 3,3 dimethyl pent2,1-ene with bromine. So if you make this pent1-ene, 1, 2, 3, 1, 2, 3, 4, 5. Pent1-ene, 1, 2, 3. So if you see, if this carbon becomes a carbocation, it is a secondary. And if this carbon becomes a carbocation, so it's a primary. Ethene with a bromine. So in ethene, there are 2 carbons only. So this is going to form a primary carbocation, and this one is also going to form a primary carbocation. Methyl propene. So propene and methyl. So this carbon is going to form a tertiary carbocation, and this carbon is going to form a primary carbocation. Are you guys getting this? My screen is again stuck. Okay, see. Propene. So this carbon is going to form a secondary carbocation, and this carbon is going to form a primary carbocation. So see, in this we are getting tertiary, which is most stable one. So A, B, and D goes wrong, and C is the correct answer. Is this clear to all of you? Now, question number 32. Halogenoalkanes react with hot ethanolic potassium cyanide. Okay. The reaction mechanism is SN1 or SN2. It's SN2 when the halogenoalkane is primary, and it's SN1 when the halogenoalkane is tertiary. Which statement is correct? All secondary halogenoalkane reacts with SN2 mechanism. No. Secondary can react with both, with either SN1 or SN2. Both the halogenoalkanes and cyanide are involved in the initial step of SN1. No, in SN1. In the initial step, only carbocation is formed, then nucleophile would attack. So B is wrong. Chloroethane reacts with cyanide by SN1. So chloroethane is a primary one. So it goes with the SN2, not with the SN1. So C goes wrong as well. So it means our correct answer is D only. The SN2 mechanism involves a short-lived negatively charged ion transition state. Yes, that's what happened. There is a intermediate transition state where we get a carbon where the substitution is taking place with the 5 bonds. 2 bonds are not the complete bonds. Question number 33. X, Y, and Z are 3 isomeric alcohols. Okay. 1, 2, 3, 4, 5 carbons. So it's C5H12O. 1, 2, 3, 4, 5. So it's also C5H12O. 2, 3, 4, 5. So it's C5H12O. Okay, all of these are alcohols. So if you see, this one is a primary alcohol, this one is a secondary alcohol, and if you see, this one is a tertiary alcohol. Separate samples of each alcohol are formed with mild oxidizing agent, and results are noted. One of these alcohol, when dehydrated, gives a pair of cis-trans isomers with the molecular formula C5H10, which Roy is correct. Reaction with mild oxidizing agent. So obviously, with a mild oxidizing agent, it will undergo oxidation because primary. It will undergo oxidation because it's primary. That's X and Y. But oxidation would not occur in the tertiary one, right? So A and B goes wrong for this reason, because they are saying that Z is also oxidized. Okay, now who is going to get cis and trans? So if you see here, the OH is on the terminal carbon. So if we get the alkene, 1, 2, 3, 4, 5. So the double bond is over here. So we are not going to get the cis trans isomer because it's on terminal 1. And if you look on the other one, 1, 2, 3, 4, 5, the OH is on the third carbon, right? So it is going to form this, and this one shows cis trans. So Y is showing cis trans, Y only. So this goes correct and this goes wrong. So D is the wrong answer and C is the correct answer. Is this understandable to all of you? Yes, very good, Hassan. C is correct. Now, question number 34. Compound D gives a pale yellow precipitate with aqueous alkaline iodine. What could be the compound D? So, if you see, alkaline iodine is given by aldehyde or ketone if they has this group, or it is given by alcohol if that alcohol has CH3, CH, group. Okay. So, if you see, it's a pentanol. So, it means OH is on the first carbon, right? And then CH2 and then so on. So it's not CH3 over here and on its neighbor, it's CH2, CH2 and CH3. So this group is not present in A, so A goes wrong. Now if you see pentane to all, so CH3, CH, OH, then CH2, CH2, and then CH3. So see, this group is present over here. So second is third correct answer. It's on third carbon, the OH is there. So OH must be next to the terminal carbon. So C goes wrong as well. And 2-methyl pentane to all. So over here, if you see 2-methyl pentane to all, it means there are 5 carbons, 1, 2, 3, 4, 5. Yeah. Over here, OH and 2-methyl. So over here, OH. So see, it's not CH3CHOH. It is CH3CH3. It is CH3CCH3OH. So D goes wrong as well. So B is the correct answer. Is this clear? Now, question number 35. The mechanism for the reaction between ethanol and hydrogen cyanide starts with the step shown. Yeah, that's correct. Now, what is the correct structure of the intermediate ion formed and what is the next step in this mechanism? So the intermediate ion formed does not has a double bond. So these two has a double bond makes A and B goes wrong. This is the triple bond that is correct. And C, oxygen got a negative lone pair and it attacks. So D is correct and this attack is wrong. So C goes wrong as well and D is our correct answer. Is this clear? I don't know why my screen is sticking. Question number 36. Which compound reacts with 2,4-dinitrophenyl hydrazine? So it's an carbonyl, right? C double bond O. Whether aldehyde or ketone both can undergo, but does not react with tolerance reagent. So it's a ketone only. Ketone does not react with tolerance reagent. So if you see it's an aldehyde, it's a ketone and acid. So it's a ketone, so it can be an answer. It's an aldehyde, no. It's an aldehyde, so no. And over here, it's an alcohol. So alcohol won't react with 2,4-DNPH, 2,4-DNPH, ketone and aldehyde both react, but with tolerance reagent, aldehyde react and ketone won't react. So A is left, so A is the correct answer for question number 36. Now, question number 37. Compound X has a stereoisomers. Okay, so if stereo means and form a precipitate with Fallon's reagent. So it means it's an aldehyde. Okay, which structure of the compound X would be? So this is aldehyde, this is ketone, so B goes wrong. This is ketone, so C goes wrong. This is an aldehyde. Okay. If you see, this is a carbon-carbon double bond over here, but both sides has the same group, so no cis trans. So if no cis trans, so it means no stereoisomerism, so A goes wrong as well. And if you see, this is the chiral carbon, so there is a optical isomerism, which is a type of stereoisomerism. So D is the correct answer. Okay, please guys give me a minute. Question number 38. Which reaction will form propanoic acid? Okay. Acidic hydrolysis of propyl ethanoate. So propyl ethanoate would be CH3, CH2, CH2 propyl, and ethanoate would be CH3, C double bond O and OC double bond O CH3. So on hydrolysis, we are getting this OC double bond OCH3 and over here OH. So see, it's ethanoic acid, so A goes wrong. Alkaline hydrolysis of ethyl propanoate. So alkaline hydrolysis will give me a salt, right? Not the acid. So B goes wrong as well. Acidic hydrolysis of propane nitrile. So propane nitrile is CH3, CH2, C triple bond N. So on acidic hydrolysis, yeah, it will give me propanoic acid CH3, CH2, CO2H. And acidic hydrolysis of ethane nitrile. So it will give me ethanoic acid. So D goes wrong as well. And C is the correct answer. Is this clear to all of you? Lactide is an intermediate in the manufacture of a synthetic fiber. Okay. When a compound on heating with an acid catalyst can produce lactide, which compound? Okay. So if you see, if I just break it, if I hydrolyze it, so see, it will turn into, it will break from this and it will turn into this. So see, over here we get an alcohol and over here I get a carboxylic acid. So if I start numbering from here, so 1, 2, and 3. So if I try to give a IUPAC name to this one, so it is going to be 2-hydroxy propanoic acid, isn't it? So it means it is formed from 2-hydroxy propanoic acid. So hydroxy ethanoic acid goes wrong. 2-hydroxy butanoic acid goes wrong. 2-hydroxy propanoic acid is correct. 3-hydroxy propanoic acid D goes wrong. So C is our correct answer. Is this understandable? Now question number 40. The diagram shows the relative abundances of different isotopes of lead in a sample of lead ore. The abundance of 208 is half that of 206. Okay. The abundance of 208 and 209 are equal. Okay. What is the relative atomic mass of lead in the sample? Okay. So we know the formula of the atomic mass. If you see, it's 50 and they are 25 and 25, right? So 50 times 206 plus 25 times 208 plus 25 times 209 divided by 100. Can anyone calculate it and tell me the answer? It's 25 times 209. Yes, can anyone please calculate and tell me the answer? 20725. 0.25. So it's this one. So C, D, and A goes wrong, and B is the correct answer. So here we have ended the paper, and inshallah we will have a one more class tomorrow. We will going to start another paper. So see you everyone in the next class. Okay. Till then, take care. Goodbye and Allah Hafiz.